one of top university in the world. And good job. And just keep up the good work. Not for yourself, not only for yourself, but for your parents and family. And welcome, my student. Okay. Seperti yang kamu lihat di skrin ni, it is now my turn lah to teach you all a new chapter, that this one that you haven't heard before in your SPM. Then after you have gone through Dr. Said's lecture in linear motion, and then you go for Dr. Salmia for dynamic, which is forces and motion, and also you just finished with Dr. Ungku for momentum and collisions. So as stated here in my slide, I'll be teaching you guys the rotational mechanics. So basically, we will study about the motions of an object that move in a circular path. Okay, so jangan risau, this is more or less the same with the linear motion, only the parameter that yang kita gunakan in circular motion it's almost the same. So sometimes I will use circular motion, sometimes I will use rotational motion, but basically both are the same terms. Okay, next. Okay, just a little bit about me. Some of you may know me, some of you may not. So maybe you pernah nampak I juga waktu dekat MSKP. I think I give you a briefing about a Google Classroom. And also my name is Mohd Fahmi, Dr. Mohd Fahmi, and I'll be teaching you guys the rotational motion, but for the part 1 lah. So they will have a part 2 and it will cover by Dr. Izlina. So you can call me Dr. Fahmi or Sir or whichever you want lah. Okay, and then during my SPM, it was a long time ago, I was a Science Geo student. And then I did my foundation in Negeri Sembilan Matriculation College. Then after the matriculation year, I did my degree in telecommunication engineering in 2009 here in UM. And after 4 years there, doing the degree, I did not directly continue my master, but I got a job in Bank Negara as a network engineer. And then I decided to quit. And I further my master studies because to become an academician is always my goal lah, because I am very passionate to teach lah. Okay, and then after my master study, I got an offer directly. I got an offer from UM also and a scholarship, and I finished my master, I think almost 4 years. And my area of expertise is fiber optics. So as you can see here on my slide on the left side, it is actually a fiber tower. So fiber tower ni dia adalah a machine that can fabricate 100 km of fiber. So for 4 years lah, my life was about fabricating a new kind of optical fiber lah. So anyone here knows what are the application of fiber optic ataupun optical fiber? Siapa yang tahu?
Telecommunication purpose.
Yep, telecommunication purposes. Yep, internet. So banyak sekarang ni all of the internet they move ataupun they change to the fiber optics. Other than the telecommunication, fiber optics juga ni dia berfungsi. It can be function as a sensor tau. Macam kita nak sense dengue dalam darah kita boleh letak atas fiber optic like a short one. And then it can detect the virus. So I think I will show you fiber optic here in my, I don't know if you can see or not. Okay, this is the fiber optic. You can see or not? It is very small. It's just like a hair. So during my 4 years, okay, okay, how about I put it in front of my cam? No, still no. So you can see because it is very small. Yeah, it's just like a hair. So I during my 4 years, I think saya buat this fiber optics like a new kind lah. A lot of function ataupun banyak fungsi-fungsi fiber optic other than telecommunication. So I did the sensor based on fiber optic and it can detect a dengue virus. Okay, so next. Penat pula saya membebel ni. Okay, and also allow me to converse in English and a bit lah kalau tersasul in BM, so you just pardon me. Okay, and then during my teacher ataupun during my lecture, I will use ClassPoint as a teaching tool. Okay, how to join my lecture using ClassPoint? Okay, you boleh interact with me, you boleh answer and everything, and I will send a link to join in the chat box, also the class code. And please put your name together with your group. So for example lah, macam Hafiz from FM2. So he will write Hafiz FM2. Okay, and then I just want to warn you, since this is my first time to use the tools with a large number of participants, so it might not work. So since there is a limitation about 200 people, so if there's some, I think this class will not exceed 200, so it should be okay. And I hope you can participate lah. Okay, I will copy paste the link to the chat box. Okay, wait Okay, the link is this one. And also the class code is 69301. Okay, you go to this one, you put the class code and then you put your name plus with the group and then you may join. Okay, I will wait like 30 seconds or 45 seconds before I start our lecture. Okay, good. Anyone yang ada problem to join the class, please let me know. I will guide you. So by rights, if you join this, you also can see my slide. And then also if you want to see by using your Teams also, no problem. So basically it will be the same lah. Okay, sekejap. Okay, so menunggu kawan-kawan lain masuk. Okay, I will proceed to the next slide. Okay, so this is relatively like I will brief you what will I teach for 8 hours or 8 lectures. So for the first lecture today, we will study about kinematics of rotational ataupun circular motion. Okay, and then at this lecture you will study ataupun you will define the angular displacement, angular velocity, angular acceleration, frequency and period. So if you may heard about this in linear motion, macam velocity, displacement, acceleration, so you have already calculate ataupun use formula, the kinematics formula yang you use lah. Kita ada 4 kinematic equation. So in angular motion ataupun in rotational motion juga, we will use that thing. But the terms is a bit different. We just put angular dekat depan tu, macam angular displacement, angular velocity, angular acceleration, and also we will study about frequency and period. Okay, and then in lecture 2 tomorrow, we will study the rotational motion but with constant angular acceleration. Then yang ni kita akan guna the 4 kinematics equation yang kita guna in linear motion, but that one we will change it to angular parameters lah. Okay. Okay, and then the third lecture, we will go for centripetal acceleration. Okay, how we want to derive it and then use the equation for centripetal acceleration. And for lecture 4, we will masuk the dynamics sebab for first, second and third lecture is all about kinematics. And for the fourth lecture, we will study about dynamics of the circular motion. So if siapa yang tak tahu what are the differences between kinematics and dynamics, kinematics ni more to the motion yang without force. Dan kalau dynamics ni kita akan campur force lah. So that's why kita akan belajar centripetal force. So we will derive and then use the equation untuk centripetal force. Okay, and then the fifth lecture, also the dynamics of the circular motion, but we will use that that dynamics of the centripetal force ni, kita akan solve the problem involving motions yang ada motion yang the object that move on the level curve ataupun flat curve, the terms yang sama, and bank curve. Apa beza, what is the difference between level curve dengan bank curve? Level curve ni dalam membulat tapi dia level, dia flat. But untuk bank curve dia membulat, the track tu membulat but dia bank, a bit bank, macam dia sengit sikit lah. Kalau you pernah tengok Kirin Azizul Hasni Awang yang naik basikal tu, so they will have a track yang flat and then also they will have a track yang a bit bank. So that's why nanti kita akan kira force yang force yang terhasil when an object move on the bank surface ataupun on the flat surface. Okay, nanti kita tengoklah what are the differences and which one is safer, adakah di bank ataupun di flat curve. Okay. And then the sixth one, kita akan belajar circular motion in a horizontal plane. Okay, we will solve the problem involving motions in a horizontal circle, but in lecture 7, we will use that knowledge to solve the problem using to solve the conical pendulum motion. Sebab conical pendulum ni dia menggunakan horizontal plane as a circular motion. Okay, and then the last lecture I will go after we do the horizontal plane, kita akan buat circular motion in a vertical plane. So we will solve the problem involving motion in the vertical circle. Okay, and then for the last 4 lecture that will be covered by Dr. Izlina, this one is more to dynamics, so and also the application. So the following 4, center of mass, torque, and then moment of inertia, and parallel of axis theorem, rotational kinetic energy, circular angular momentum and conservation. This one already you study, but that one is in linear. And but untuk yang ini kita lebih kepada circular punya motion. Okay, memang ada term-term yang tak pernah dengar, but don't worry, it is very easy. So kalau you focus in class, you akan dapat. Okay, so these are the learning outcomes untuk part 1. So if you baca kat sini, okay, before that I will inform you guys, because untuk lecture notes you guys boleh download from the Spectrum. I will upload the lecture a day before the lecture. Maksudnya kalau lecture 1 adalah hari ni, malam sebelum tu saya akan upload. So you guys can baca dulu the lecture before you come into my class. But bear in mind lah, maybe ada a bit of error here and there, so nanti you betulkan sendiri. Okay, so these are the learning outcomes. So if you read here, we need to define what angular displacement, what angular velocity, angular acceleration, benda yang sama, displacement, velocity, acceleration, but it's all about the circle ataupun circular path. And then we will study about frequency and period. And we compare the equation between rotational and linear motion. Nanti kita buat comparison and derive and use the equation for tangential velocity and tangential acceleration. Apa perbezaan tangential velocity dengan angular velocity? So nanti kita akan tengok. And we derive and use the equation of centripetal acceleration and centripetal force. Yang keempat ni, this one dah start masuk dynamics of the circular motion. And then we have to solve problem involving motion in level and bank curve yang saya cakap tadi. And then we need to solve the problem involving motion in horizontal circle, vertical circle, and also conical pendulum. Okay, so kita masuk lecture 1. Itulah penat saya membebel untuk first lecture, introduction, but don't worry. Okay, now kita start masuk lecture 1, which is kinematics of rotational motion ataupun circular motion. Both are the same, just different terms. Okay, we need to define angular displacement, angular velocity, angular acceleration, and also frequency and period. So after we describe all these three, angular displacement, velocity, and acceleration, and then kita akan cari the relationship between linear and also angular motion ataupun circular motion. Alright, next. Okay, what are the differences between linear motion and circular motion? So kalau you tengok dekat sini, the car move in one direction and also in circular motion. Okay, I'll open the... Alright, I'll open the submission, then you can enter and you can jawab lah. Okay, what are the differences between linear motion and circular motion? Okay, boleh isi on the box and then you just submit. Then I will see your answer. Okay, no one answer? Come on guys, dia jawab je. Apa-apa, tak salah pun. And tak ada yang betul. Okay, I can see some already responses responded to this question. So I'll show here lah. Okay, okay boleh nampak dia ada yang tulis linear motion in a straight line and circular motion in a circle, correct. Linear motion in a straight line, okay, correct. Linear motion occur in straight line, circular motion in circle. Ramai yang jawab macam tu. Okay, so these are the answer yang saya jumpa lah. Okay, kalau you boleh nampak boleh nampak kan? Okay, linear motion shows the object moving as in a straight line dari Naim Wirdas FP1. Meanwhile, circular motion shows the object moving in circular. Yep, correct. Thank you Naim. Next. Ramai yang jawab macam tu. Linear daripada Ikmal Ashraf FJ1. Linear motion in a straight line but circular in 360 degree. Correct. Okay. So kebanyakannya betul lah. Okay, jap saya punya slide dah lari. Okay. Okay, so kita tengok apa jawapan dia. Okay, so linear motion betul, moving in a straight line in one dimensional ataupun dua dimensional. So dua dimensional ini lebih kepada projectile motion, and for circular motion, a movement of an object along the circumference of a circle ataupun rotation along a circular path. So saya tengok tadi memang jawapannya banyak yang betul. Okay, good guys. Okay, then kita proceed with the next slide. Okay, kita tengok apa itu angular displacement. Okay, so angular displacement, okay, kalau kita tengok this is the car. It moved from P to Q, okay, and then P to Q is in time T, and after time T, the object has moved daripada P to Q dengan ada satu angle which is theta here, okay, and then object has moved a distance. The object moved a distance of S. This is the S. So S we call it as arc angle ataupun arc length. Sorry, arc length bukan angle. Tapi arc length ni it is correspond to the angle theta. Okay, then before we go further ataupun before I define what angular displacement is, saya akan describe a bit of parameter that used in the angular displacement. Okay, first sekali, what is the circumference for a full circle? Macam kita dah belajar since sekolah menengah. Okay, circumference of a full circle is 2 pi r. 2 pi tarapkan dengan the radius. And then we just change the 2 pi to the right and to the left hand side. It is equal to the S over r. And then theta is the angle in radians, okay, and is defined as the arc length S along a circle divided by the radius. Jadi theta is equal to dia ada relationship dia antara arc length and also radius. Thus, theta is equal to 2 pi radian. We know that one circle is 2 pi radian ataupun 360 degree. Jadi 2 pi radian ni we equate them with the 360 degree, and 1 radian is equal to 360 over 2 pi. Jadi we can change ataupun we can convert the degree into radian. Okay, next soalan. Question 1. Convert 30 degree to radian. Okay, I'll open the submission and you guys may start to jawab sekejap Okay. Alright, so now you can jawab. You pilih A, B, C atau D. Okay, laju guys. Ada yang jawab 8 orang. Okay, nice. Simple kan? Tak susah. Yeah, we'll open for 20 seconds more. Saya akan bagi you practice untuk jawab dengan laju because since our last quiz, ramai yang jawab quiz boleh jawab but they have a limitation in time. Jadi ramai yang stop lah daripada menjawab. Tak sempat nak jawab kan. If we practice this. Okay, 10 more seconds. Then I'll close the submission. Okay, so most of you jawab C, ada 3 orang jawab B and ada seorang jawab A. Okay, so macam mana? Ada yang jawab B, ada yang jawab A. Okay, wait Okay, let me open my whiteboard. Kita tengok apa jawapan dia. Mana pula pen? Okay. Okay, so the question is 30 degree to radian. Okay, how to answer this? Very easy, guys. 30 since 360 degree is equal to 2 pi radian. Jadi 30 degree we just darabkan dengan 2 pi bahagi 360 or 30 times pi bahagi dengan 180 lah. So you guna calculator, you akan dapat berapa? 30 times pi
0.52.
Yeah, correct. 0.52 radian. Okay, so jawapan dia adalah C. Okay, siapa yang satu just take note macam mana you calculate. Alright, next. Then now I define lah what is angular displacement. So angular displacement, kalau kita tengok here, the car tadi just move from P to Q and then dia teruskan perjalanan from Q to R. So object move from Q to R in a time interval of delta T ataupun T final minuskan dengan T initial. So through an angle delta theta. So we call it delta theta. So delta theta, what is delta theta? Delta theta is theta final daripada this one from P to Q. This is delta theta final minuskan dengan initial theta yang dia jalan daripada P to Q tadi. So the delta theta adalah T final minus the T theta initial and we call this as angular displacement. So angular displacement is not the arc length tadi. Arc length tadi adalah more to linear path. The angular displacement adalah yang theta. Sebanyak berapa jauh dia jalan dalam theta radian tu. And the unit is radian. Okay, kita tengok soalan. If you guys boleh dapat ke tak. Alright, so question 2. Okay, this one. Question 2. Fatimah goes around in a circular track that has a diameter of 7 meters. If she runs around the entire track for 50 meters, what is her angular displacement? Okay. So boleh kira. Seorang dah jawab. Okay, 5. Seorang jawab B. Kita tengok kenapa dia jawab B. Seorang jawab C. Okay. But majority of you jawab A. Okay, I'll close the submission. Tak ramai yang join So you guys kena laju sikit lah jawab. Okay, I'll close the submission. Okay, tengok ramai yang jawab A. Ada 2 orang jawab B, 3 orang jawab C, seorang jawab D. Okay, kita tengok siapa yang jawab A, B, C dan D tu. Kita tengok apa problem dia. Okay, let me open my whiteboard. Okay. So Fatimah goes around a circular track that has a diameter of 7 meter. So kalau kita lukis bulatan kat sini, diameter dia kat sini 7 meter. Pardon my drawing tak cantik, susah sikit nak lukis. So if she runs around the entire track for a distance of 50 meter. So dia lari kat sini, dekat sini katakan 50 meter. Okay, and then what is her angular displacement? So angular displacement yang saya cakap tadi, ianya adalah theta kan. So how to find theta? So we use the equation of, okay, dia bagi tahulah kita just list down the parameter given. The diameter is 7 meter, and then they run on the track of 50 meter. So this is the S lah, the arc length. Jadi what is her angular displacement? So we use the equation of S is equal to R theta. Jadi angular displacement is equal to the distance divided by the radius. So the distance is 50 and the radius, kena be careful here sebab question ask for diameter. So we have to divide it by 2. The radius is equal to 7/2. Okay, and then kita divide by 3.5. Jadi jawapan dia adalah, anyone?
14.29.
14.28 atau 29. Okay, so radian. Okay, boleh Yang salah tadi boleh Okay, never mind. Okay, kita tengok soalan seterusnya. Okay, now we already know what angular displacement is. Angular displacement, the unit is radian. So kena ingat. I always memorize that angular displacement is not in meter, but it's in radian. Okay, now we define angular velocity. Okay, angular velocity, if we see from this, okay, the curve from Q to R, but kalau from the linear motion, the velocity is always the displacement divided by the time. But for here, for angular velocity, it is actually the ratio of angular displacement, but the delta theta, then we divide by delta t. Benda yang sama, displacement divide with the time. But now we have to divide the angular displacement dengan the delta t ataupun time lah. Okay, and then we belajar about instantaneous angular velocity. So what is instantaneous? What are the differences? What is the differences between average angular velocity and also instantaneous angular velocity? So kalau kita tengok kat sini, a limit of the average velocity as the time interval approaches 0, and we have to differentiate it. So apa maksud dia? Okay, if you run from point A to point B, let's say point A to point B is 10 meter. Okay, and then during the 10 meter you run ataupun during the 10 meter you jog, okay, ada yang part yang maybe dekat time is equal to 2 second, you lari maybe 7 meter per second. And then around 5 meter you lari about 6 meter per second. And then yang kat hujung you already start penat, you slow down sikit, maybe the average is the velocity is 2 meter per second. And then for average velocity we have to cari je dia punya the distance divided by the time. So dia average kan berapa velocity yang you lari. But untuk instantaneous bermaksud at the particular time. Contohnya macam okay, what are the velocity that you run dekat jarak 3 meter after the starting point. So dekat at the specific time at the t is equal to what time, what second, maybe 2 second, berapa velocity you. Okay, itu adalah instantaneous. So that's why dia kita guna differentiation. But don't worry, I will show you an example of the instantaneous angular velocity punya question. Okay, and then unit untuk angular velocity is the radian per second, because we know that angular velocity is angular displacement divided by time. Angular displacement is in radian, time is in second. So radian divided by second, it is radian per second. So that is angular velocity. Alright, so kalau saya laju sangat, just let me know, then I will slow down my pace lah. Okay, so now I will explain to you guys what frequency and period are. Okay, so other than we use the angular displacement divided by time, then we will get angular velocity. We also need to explain about the frequency and period. So rotational frequency is defined as the number of revolution per minute per unit time. So kalau tengok kat this is a blue ball yang dia jalan daripada satu point on the top, and then dia akan move satu round of the circle and it will turn back into its original position. So this one kita panggil dia one rotation ataupun one revolution. Okay, and we know that dalam satu pusingan kepada tempat asal ke tempat asal tu, we call it time ataupun period. And period is defined as 1 over frequency. And from there, we will get what frequency is. So frequency is 1 over time. Time tu adalah dia ambil masa daripada point, the first point it start until the first point it ends. So tempat yang sama. And then we can define the angular velocity in terms of frequency. Tadi kita buat angular velocity in terms of angular displacement divided by time kan? But now is angular velocity in terms of frequency. So angular velocity omega is equal to 2 pi darabkan dengan frequency. Alright, now revolution per minute. Okay, what revolution per minute is? So one revolution, we know that one pusingan is equal to 360 degree. And then 360 degree tu we convert it into radian, which is equal to 2 pi radian. Okay, and then one revolution per minute, we know that 2 pi radian, we dividekan dengan 1 minit ataupun we divide by 60 second. Jadi one revolution per minute is equal to pi over 30 divided by radian per second. Okay, nanti kita tengok kenapa saya ajar this frequency and revolution per minute, because sometimes the question will not give you angular velocity in radian per second. They will give you revolution per minute. So you have to convert the radian per second into revolution per minute. Dia macam kalau linear kilometer per hour lah. So kilometer per hour we have to convert it into meter per second kan. But this one, if the question give you revolution per minute, you have to convert it into radian per second. Okay, question 3. A tire spins with 1500 revolution in 1 minute. So find the angular velocity of the tire. Okay, I will open this. Wait, Okay, you guys may answer. Ramai lagi yang jawab. Siapa yang boleh jawab, please answer it. Please participate in my class so that you understand what I teach you about. Tak ramai jawab lah. Ke tak tahu? You mean the angular velocity of... Okay, ini sorry saya salah ni. Okay. 33 orang je yang jawab. A tire spin with 1500 revolution in 1 minute. Find the angular velocity of the tire. So basically, it will ask you to convert 1500 revolution to revolution per minute to angular velocity. Okay, I'll close the submission. Tengok Okay, tengok jawapan dia. Ramai yang jawab B, which is 35 pi radian per second. Ada yang jawab C, 50 radian per second, and also ada yang jawab D, 16 ni orang menjawab 50 pi radian per second. Okay, kita tengok jawapan dia apa. Siapa yang salah boleh tengok apa jawapan dia. Okay, dia nak 1500 revolution per minute into radian per second. Okay, how to convert? Benda yang biasalah. Okay, we know that 1500 revolution. Okay, one revolution is equal to what radian? Satu revolution berapa radian?
2 pi.
Yeah, correct. So we have to darab by 2 pi. Okay, and then 1 minute berapa second? 60 seconds. Yeah, so that's it. So guna calculator, 1500 times 2 pi divided by 60. So we will get 50 pi radian per second. Okay? Boleh Okay, next. Soalan kedua. Determine the angular velocity if 4.8 revolutions are completed in 4 seconds. Okay, jadi macam mana nak buat? Determine the angular velocity if 4.8 revolution are completed in 4 seconds. Okay, boleh jawab. Saya buka 1 minit. Okay. Cuba kira 4.8 revolution in 4 seconds. Ready second more? Ramai yang jawab sebab kita ada 160 people here and only 63 people yang jawab. Another 100 masih lagi mengira. Okay, good. 75. Okay, I'll close the submission. Tengok. Ada 64 orang menjawab B. Okay. 3 orang jawab C. And 11 orang jawab D. Okay, apa jawapan dia? Okay, I'll open my whiteboard. Okay, dia nak 4.8, dia bagilah dalam soalan 4.8 revolution in 4 seconds. What is its angular velocity? Okay, so we know lah, 1 revolution is equal to 2 pi. Right, jadi 4.8 revolution, it is equal to 4.8 times with 2 pi. Right, and then this one is equal to 30.16 radian. So what is this actually? This one is angular displacement ataupun theta. Right, alright, and then in 4 seconds, what is the angular velocity? So we know that angular velocity ataupun omega is equal to angular displacement divided by time. Then we already calculated for angular displacement, which is 30.16 radian, and then we divide by the time. The time is 4 seconds. So apa jawapan dia? Anyone yang kira?
8.5.
7.5
5
radian per second. Ya, senang kan? Senang
Senang.
Okay. Alright, next.
Senang.
Kita dah buat angular velocity. Okay, angular velocity dah, angular displacement dah. Now kita pergi kepada angular acceleration. Jadi benda yang sama, in linear motion, acceleration is equal to velocity divided by the time. Okay, but for angular acceleration, it's still the same thing. Angular acceleration, you need the label is alpha. Okay, yang macam ni, this is alpha. Okay, and then alpha ataupun angular acceleration average is equal to the changes in the angular velocity divided by the time. So the changes in the angular velocity is angular velocity final minuskan angular velocity initial. Okay, that is the angular acceleration atau kita panggil average angular acceleration. And also instantaneous angular acceleration at the specific time of t, angular acceleration is equal to the differentiation of omega to the time. Okay, nanti I akan bagi soalan dalam bentuk instantaneous angular acceleration juga. And the unit for angular velocity, sorry yang ini bukan angular velocity, the unit of angular acceleration. Nanti you betulkan dekat you punya slide. Sekejap mana saya punya. Okay, unit for angular acceleration is yang ini angular acceleration is radian per second. Radian per second square. Saya dah betulkan, nanti you betulkan kat slide yang I dah upload dekat Spectrum. Okay, next soalan. Okay. If the angular velocity of body in rotational motion changes from 0.5 pi radian per second to 0.75 pi radian per second in 0.4 second. Find the angular acceleration. Okay, boleh kira. Ada seorang ni jawab laju betul. Kita tengok leaderboard, siapa yang paling laju sebenarnya. Okay, I will open for 1 minute. Another 40 seconds. Okay, 30 saat lagi. Oh, yang ni laju ramai yang jawab. Maybe previous punya question a bit difficult. Dia tak difficult lah, cuma you kena get used to parameters yang dalam rotational motion. So angular velocity, angular displacement, angular acceleration, and also revolution per minute. So once you grasp the concept, then you'll be fine lah. Don't worry, nanti banyak latihan. Okay, I'll close the submission. Tengok jawapan. Okay, 122 orang menjawab B and 2 menjawab C. C jawapan dia 0.35 radian per second square. Okay, kita tengok apa jawapan dia. Okay, let me open my whiteboard. Okay, so soalan dia bagi the initial angular velocity is 0.5 pi radian per second, and then the final angular velocity is 0.75 pi radian per second, and also dia bagi time adalah 0.4 second. So the angular acceleration is equal to delta omega divided by delta t, and we know that the delta omega here is 0.75 pi. Then we minuskan dengan the omega initial is 0.5 pi. Then we dividekan dengan 0.4. Right. So jawapan dia? Anyone?
0.625 pi.
Yes, 0.625 pi radian per second square. Okay, so yang salah kira tadi, you tengok yang ni so that you tahu apa kesalahan you. Alright, next. Kita ada 10 minit lagi. We go for second question, which is the angular displacement of an object in rotational motion depends on time t. According to the relation, theta is equal to 2 pi t power of 3 plus pi t square plus 3 pi t minus 6. So find the instantaneous velocity and acceleration at time is equal to 2 seconds. Jawab. So instantaneous velocity and instantaneous acceleration. So kita kena guna differentiation. So we have to differentiate d theta time, and then we substitute the time into the equation, then we will get the instantaneous velocity. Okay, yang ini tak ramai yang jawab, maybe tak tahu. But that's the hint. Kita kena differentiate theta terhadap t, and you will get the first differentiation, we will get velocity, and you sub the value t. So untuk cari acceleration, we have to again differentiate d omega tu dengan dt. You akan dapat acceleration dan you sub value of t. Ada 7 orang je yang jawab yang lain. Okay, I open another 20 seconds. 17 orang. Tak ramai.
Cannot brain.
Cannot brain. Okay, nanti I show you the answer. Alright, kita tengok 23 people yang jawab B, 2 orang jawab A, seorang jawab C, seorang jawab D. Ni mesti main hentam ni. Okay, kita tengok dia punya solution. Okay, dia bagi the what we call it, the relation antara theta dengan 2 pi t power of 3 plus pi t square plus 3 pi t minus 6. Okay, dia suruh cari angular velocity and instantaneous angular velocity and also instantaneous angular acceleration. So untuk dapatkan omega, we have to differentiate. Sebab kita tahu omega adalah theta divided by dengan time kan. Jadi kita kena differentiate this one, d theta terhadap dt. Jadi d theta terhadap d time is equal to, okay, we differentiate this. Kita bezakan dia. 2 pi t kuasa 3 is equal to 6 pi t kuasa 2. Okay, and then kita differentiate pi t power of 2, dia akan jadi 2 pi t. Right. And then kita differentiate 3 pi t, kita akan dapat 3 pi. Kita differentiate 6 dapat apa?
0.
Telur ayam.
Telur ayam. Jadi kita masukkan t is equal to 2. Then we sub into 6 pi 2 kuasa 2 plus 2 pi. Inilah jam mat dah pula. 2 dah 3 pi. And then kita akan dapat 2 kuasa 2, 4 darab 6, 24 pi plus 4 pi plus 3 pi. So we will get
31.
47 pi. Good. Okay, now this is the instantaneous velocity. Instantaneous angular velocity ataupun omega. And then we want to find alpha, angular acceleration. So we have to kita boleh buat lagi sekali differentiation. Ataupun this one is d theta over dt, dan kita buat lagi sekali which is equal to d omega over dt. Sebab ini adalah omega samakan dengan this one kan. So d omega over dt is equal to, okay, we buat this one, d theta yang ini, this one, ini adalah omega, kita differentiate again lagi sekali. Okay, kita differentiate again lagi sekali. So 6t kuasa 2, we differentiate, we will get 12 pi t. Okay, 2 pi t, kita differentiate dapat 2 pi, and 3 pi akan dapat kosong. So we masukkan a value of 2, 12 pi, darabkan dengan 2, campur 2 pi. So 12 darab 2, 24 pi plus 2 pi. So we will get 26 pi. Okay, betul So jawapan dia adalah B. 31 pi radian per second. This one unit dia radian per second. This one unit dia radian per second square. Okay, faham for instantaneous velocity? Good. So kita next. Okay, so kita nak belajar the relationship between rotational and linear quantities. Okay, this one is more on deriving lah, macam mana kita nak relatekan between the rotational and linear quantities. So analogies between angular and linear quantities. Okay, firstly, we know that consider an object rotates through an angle delta theta, which is from theta initial to theta final. Okay, and arc length is delta s. Okay, delta s tu adalah dekat sini. Okay, this is delta s. Ini adalah delta s. Okay, and in time interval delta t. So we know that delta theta is equal to s over r, daripada yang kita dah tahu tadilah, dia hubung kait antara delta theta dengan s over r. Okay, then divide both sides of the equation by delta t, and we akan dapat delta theta over delta t is equal to yang over r dekat bawah ni saya keluarkan dia jadi 1 over r, and is equal to delta s kita dividekan dengan delta t, sebab both side kita kena divide by delta t. Alright, so if delta theta small, jadi bila dengar je perkataan delta theta small, dia mesti menggunakan differentiation. So delta theta over delta t yang ini dia jadi d theta, differentiate between d theta over dt, and then untuk yang part yang ini dia jadi ds over dt. So dia dah jadi bentuk-bentuk yang inilah, d theta dt, the differentiate of theta to dt is equal to 1 over r ds over dt. Alright, from here we know that d theta dengan dt ni adalah omega. Okay, dia adalah omega, we know. Angular velocity. And ds dt adalah equal to v tangential. Apa itu v tangential? Ianya lah tadi kan kita tahu yang dia bergerak sebanyak s tadi. And dekat this point, kita define tangential velocity. Velocity tangential tu adalah vt. Okay, this one adalah linear part. So kita dah dapat hubung kait antara angular velocity dengan linear velocity. So this is the relation. Vt is equal to r omega, di mana v tangential ni adalah linear. And then the omega is the angular. So kalau katakanlah dia bergerak dekat sini. So dia punya velocity tangential dia adalah yang tangent to the bulatan. So this is the Vt. Okay. And then katakan point dia dekat sini. Jadi Vt dia ke sana. So this is the Vt. And again lah, dia tangent to the bulatan. So here is the Vt. Okay. So I think I will stop here because tomorrow saya akan terangkan apakah itu acceleration, tangential acceleration pula. So tadi kita dah belajar antara velocity yang linear dengan angular angular velocity dengan linear velocity, di mana ini adalah dia punya hubung kait. V tangential is equal to radius darabkan dengan angular velocity. Okay, so before I end the class, any question from the floor?
Doktor,
Yeah.
yang R tu radius kan, yang R dalam formula tu.
Yep, correct. This is the radius, ni Yuan. Ni adalah radius. So katakan radius dia yang ini adalah radius lah. And then at this point, the tangential velocity is tangent to the surface of the circle. So this is the tangential velocity. Okay, lagi?
Doktor,
Ya, saya.
revolution per second sama dengan average velocity ke?
No, revolution per second, dia punya unit adalah revolution per second lah. So you have to, it is angular velocity but the unit is revolution per second. But in solving any circular motion punya solution problem, so you have to convert everything ke dalam radian per second. Okay, so contohlah kalau dia bagi 4 revolution per second, so kena convert to radian per second. Cara dia 4 revolution per second darabkan, revolution ni kita tahu 2 pi lah, so second tak perlu tukar lagi sebab kita dah memang nak radian per second, jadi dia adalah 8 pi radian per second. Boleh? Siapa? Akmal tadi yang tanya.
Okay. Thank you, Doktor.
Alright. Okay, Khairul.
Revolution per second sama ke dengan frekuensi?
Revolution per second, yes, I can say, kalau revolution per second, frekuensi bermaksud 1 over time. Jadi frekuensi unit dia adalah 1 per second. It is not revolution per second. Revolution per second is angular velocity. Jadi kalau frekuensi tu dia punya unit mesti per second ataupun kita guna hertz. Macam mana nak cari frekuensi? Ianya daripada period. Satu kali dia jalan pusingan tu, dia return balik to the original point. So that is the period. And to find the frequency, we have to inverse the period lah, 1 over t. And frekuensi unit dia adalah per second. Dia bukannya revolution per second. Revolution per second tu is angular velocity. But you have to convert it into radian per second lah. Okay, Khairul Amirin?
Okay.
Alright. Ada lagi? Tadi saya nampak macam Wan Camelia nak tanya. Siapa tu?
Can we convert the macam linear kepada angular, linear kepada circular, boleh?
Linear kepada circular, there is no conversion, but there is a relation. So dia ada relation antara velocity linear dengan velocity angular. Sebab apa? Sebab apa saya cakap? Okay, angular velocity adalah yang bergerak secara membulat. Tapi linear velocity at that particular point, macam dekat sini, the linear velocity, we call it tangential velocity, dia hanya dekat sini saja. Kita panggil dia Vt. Faham tak Aris?
Faham.
There is no conversion lah sebab the tangential velocity unitnya meter per second, tapi kalau angular velocity unitnya radian per second, tapi dia ada relation lah. If we times with the radius, dia akan dapat tangential velocity. Okay? Alright, ada lagi? 1, 2, 3. Alright, good. So saya dah upload my lecture note untuk hari ni dekat Spectrum. You guys can download and you guys can go through until tomorrow punya lecture. And also I will upload the second lecture punya notes by tonight. Then you boleh baca first all the notes, and then when you come into my lecture, at least you already get the views ataupun get already something yang you dah boleh nak tanya lah sampai yang you tak faham. Okay, so if tak ada lagi, I will end my class, and if anything you can tulis, you can approach me by PM dekat Teams ni. Okay, thank you guys. Assalamualaikum.
Thank you, Doctor.
Thank you so much, Doctor.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor.
Welcome.